Okay, so this is the question from the assignment. Uh, First part of the question is, first of all, it's a 25-mark question, so you're talking about, 12 and a half minutes to do this, tops. So, differentiate minus 2x squared plus 3x minus 12 from first principle. So differentiating by rule, you can see that the answer is going to be minus 4x plus 3. All right, that's your answer. So that's the beauty of this differentiate from first principles rule question. It's that you know the answer, and if you get it wrong, well, you can go back and fix it. Now it's only a 10-mark part A. It's only 10 marks, so bear that in mind as well. So the first thing you do, you set it up. Say what f of x is. I'm gonna just take that off for a second. Into shape. Okay. So set it up with your f of x. That's equal to minus 2x squared plus 3x minus 12. The next thing you have to do is introduce your change, which is f of x plus h, to your delta. So that's going to be minus 2 everywhere you have an x. You now have an x plus h to be squared, plus 3 times, plus 3 times, oh dearie me, plus 3 times x plus h minus 12. So multiply that out. Oops. This is turning into an acid trip. Move that over a little bit. There we go. Okay, so multiply this out, and you're getting minus 2 into the first one squared, twice the first by the second, plus the last one squared. Multiply the 3 in, you're getting 3x plus 3h minus 12. So multiply the minus 2 in here, it's minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 12. So look to see if there's anything that will cancel for you. Nothing, no, that's it, as tidied up as you can. So that's what f of x is. Now you've got to have f of x plus h minus f of x. So you're just going to be left with, technically left with h. So that line there, you need to take your f of x away from it. So minus 2x squared, sorry, we can just do this now. Probably minus 2x squared minus 2x squared, well, they're going to cancel. Plus 3x is going to, sorry, plus 3x minus the plus 3x, they're going to cancel. And the 12s are going to cancel as well. You've got minus 12, and it's going to be minus 12, which is plus 12, so that's going to cancel. So all of those end up cancelling for you. Okay, so that just leaves you with your minus 4xh, back to black, minus 2h squared, and of course this plus 3h over here. Now what you got to do is introduce a divide by h, so f of x plus h minus f of x, and you have to divide by h. Now look, it is important that you carry on and write all this stuff here as we're working our way down. There are marks going for writing down this notation on the left hand side, so bear that in mind when you're doing this question. So divide it all by h, what are you going to get? All divided by h. Well, the h goes into that, the h cancels with this, and the h cancels with that. So you now need to introduce your limit. So it's the limit, just get rid of that there, the limit as h approaches 0 of your function f of x plus h minus f of x divided by h is going to be minus 4x minus 0 plus 3. That there becomes a 0, which is of course minus 4x plus 3, which is what we said the answer was, minus 4x plus 3. So that's it done. Moving on to the next part. Make the page a bit bigger rather than the sheet. So if f of x is equal to e to the power of cos x, find f dash x. So the derivative of this, well, the derivative of e cos x is itself. Well, the derivative of e cos x is itself, e cos x. Now you've got to derive the cos x, so derivative of cos x, using the chain rule here, derive the derivative of cos x. You're going to see that it's minus sine x. So that's your answer. F dash x is equal to minus sine x e cos x. So moving on to the next part. It says hence or otherwise evaluate this. So you've got to integrate here. And you'll notice that this is very similar to what you got up here. Right? Hence the hence part. Minus sign. So all we're doing is we're missing a minus sign. So we got minus sine x e cos x. So if this had a minus sign in it, we would know that it would, when we went to integrate it, we would end up with this, right? If we had a minus sign. But we don't. So you have to introduce some minus signs to allow you to integrate. So if you remember, if you have a constant in this at any time and you want to take it out, you can before you do the integration. You can bring it to, let's say there was a 3 here, you could bring it here. So we're going to do that now, but do it with the minus sign. So I'll just write out what we have, right? We have the interval is pi over 2 and 0, and we've got sine x cos x. Now if we had them, so like you have to integrate this. Remember, there's no product rule for integration. Like if you have something like this, you know, you really probably have to think about, have I done something already in the question to help me integrate, right? So now if we had that, then we would know that this integrates to e cos x, right? So if we introduce a minus sign here and we also introduce a minus sign here, well then we've got the same thing. So that's what we do. 2 minuses to make up for the fact that it's not exactly the same as what we had in the previous part of the question. So we have the 2 minus signs there, and now we're able to integrate. So integrating, what are we going to get? Well, this becomes this, right? So that's fair enough. E cos x with pi over 2 and 0 being our interval. So this is always the upper limit, which is going to be e cos pi over 2 minus the lower limit, which is going to be e cos 0. So what is cos pi over 2? Pi over 2 is 90. The cos of 90, if you go to page 13 of your log table, you see that the cos of 90 is, of course, 0. So you've got e to the power of 0 minus the cos of 0 ironically enough, is 1. So you've got e to the power of 1. So it's minus all of this. E to the power of 0 is 1. And it's minus e to the power of 1 there. So multiply now. Multiply by this minus sign that we had to introduce because of the problem we spoke about already. You're getting minus 1. You're getting plus e to the power of 1 or plus e. And that's it done. I said 12.5 minutes, and obviously I was explaining things there that took 10 minutes. So, I mean, it's kind of a question where you could have done in probably 7 minutes or less, I'd say.